Hello, thank you for joining us. So this video we're going to look at applying Viet's theorem with the sums and products of roots of polynomial equations. So let's say that alpha and beta are the roots of this equation. Find a quadratic function of the form f of x equals ax squared plus bx plus c with roots 2 over alpha plus 1 and b over alpha plus 1. Okay, so how can we work with this? How can we work with this? Well, let's think about the roots that we want to have. Okay, so if I'm going to have a polynomial f of x with these roots, the sum of the roots is going to be equal to 2 over alpha plus 1 plus 2 over beta plus 1. Right? And if I find a common denominator, that's going to be 2 times beta plus 1 plus 2 times alpha plus 1 all over the product alpha plus 1 times beta plus 1. Okay. If I look at what I have going on here, I can go ahead and multiply some things out, and I've got 2 beta plus 2 plus 2 alpha plus 2 all over alpha times beta plus alpha plus beta plus 1. Now, why is this useful for us? Why is this useful for us? Well, it's useful in the following sense, that we know that this sum of the roots, which is given by this, must be, right, for a quadratic with an even degree polynomial, that sum of the roots must be my c over a. That's what it has to be. It's going to be my constant over my leading coefficient. Okay, what about the product of my roots? The product of my roots, that's going to be 2 over alpha plus 1 times 2 over beta plus 1. And that's going to be 4 all over alpha beta plus beta plus 1. All right? And that product of the roots is going to be opposite b over a based on Viet's formulas. All right? Based on Viet's formulas. Now, in general, we do have our initial setup that if we look at this equation, right, if we look at this equation, we can say that we actually have, right, let's rearrange it so that we have 0 is equal to 5 halves. So 0 is going to be equal to 5 halves minus 4x plus 2x squared. And the roots of this polynomial will be the exact same as the roots of the polynomial 5 minus 8x plus 4x squared. Okay. Well, the sum of these roots is going to be alpha plus beta, and that sum is going to be, right, my constant over my leading coefficient, which is going to be 5 over 4. And the product of my roots, that's going to be alpha times beta, and that product of my roots is going to be equal to opposite my term below x squared, so opposite this x, so that's going to be opposite negative 8 over 4, which is 2. So how can we use that? Well, for my new polynomial, right, for this new polynomial, I know that that sum of the roots is going to be equal to 2 times alpha plus beta plus 4 all over alpha times beta plus beta plus 1. Well, according to this, it's going to be 2 times 5 over 4 plus 4 all over, right? Alpha times beta is 2, so 2 plus 5 over 4 plus 1. All right, so a challenging problem we have here. And I know that my product of my roots, right, is going to be 4 divided by, right, the same denominator there, which is 2 plus 5 over 4 plus 1. I personally am not too much of a fan of working with fractions if I can avoid it, so I'm going to multiply numerator and denominator by 4. If I multiply numerator and denominator by 4, that's going to give me in the numerator 10 plus 16, and in the denominator I'm going to have 8 plus 5 plus 4. So that gives me 26 all over, what would that be, 17 if I'm not mistaken? And similarly, for the product of the roots, I'd have 16 over 17. So what does that mean for me? What does that mean for me? What that means is that I can figure out this new f of x. Let's get a different color for it. That means that f of x, I can say, is going to be equal to, right, let's see here, 17 x squared minus 16x plus 26. And the reason for that is that, once again, the sum of the roots is going to be equal to c over a, and the product of the roots is going to be equal to opposite b over a. So if c over a is 26/17, then c is 26 and a is 17, and if opposite b over a is 16 over 17, then b is opposite 16. So a fairly tough problem, but a nice challenge for this advanced math class that is IB, higher level maths. So using Viete's theorem. Thank you for your time.